How's it going, everybody? Eulier Gonzalez here, and in today's we're going to talk about is the async nature in JavaScript, which is taking note out of this course taught by Will Sentence, a software engineer that has previously worked building Icon, which is this P2P applications, and he's currently the CEO at Codesmith, a software engineer in machine learning residency, headquarters in London, New York, and California, where the goal of today's video, or from this course first, and then we're going to talk about from today's video, is that first, we're going to take a look at the EX6 and ES7 features that now brings us to deal in specifically on the async nature in JavaScript. We're going to see how JavaScript nature was handled before. We're also going to take a look at how is this new way of accessing data through iterators, as well as how can we control the data flow through generators. How can we make sense by combining those concepts into the async in a way, something that right now I don't know how you can do that, how you can combine that, but we're going to see in this course. And along this course, we're going to see diagrams to have a better precision and understanding this new concept. So the goal of today's video is to now take a look at this section called promise, and then move on to the next one, which is the iterators and how it can combine that with the generators. So this is the course structure here. So far we have talked about the introduction. We're gonna make a quick recap about that, the async natures of how JavaScript handles asynchronicity, promise how this is now a more convenient and readable way to interact with async interactions, iterators, which is this new way of how can we think about accessing data. This is for accessing data, and generators is for control data flows, and that will going to make much more sense when it comes to define async in a way and understand that behind the scenes. So the fundamentals here of the JavaScript part of this introduction is to, hey, this is the thread of execution. We can also have something called the global variable environment. We also have something called the global content execution. Anytime we write a functions and when we run it, we create a function execution context that inside of that it has a thread. It's a local thread of execution and a local variable environment, that when you return a function, it creates a closure for that. You can think of this closure as, or well, after all, that's what it is. This store that allows you to persist data reference. So in other words, is that when you returning a function from another functions, effectively are creating a closure, which means that from these functions, you can now access to the variables outside of that scope, that function scope. So you can access variables from the inner scope. You can access variable of. You can access outer function variables from the inner scope, and that is something important because it allows you to now have a persistent place where you can store data. So for example, you want to have the score on a game, perhaps in a ping-pong game, on the browser. So also you can perhaps want to modularize your applications that you want to only run functions once. Okay, that's another interesting mechanism to do that. Or perhaps you want is to memorize functions or results in this computation. That's what also closures allow you. So closure would allow you to do these memorizations. So for example, giving a particular input, okay, if you already calculate that, so you don't have to recompute that, you just provide the result. An example of that, and a very silly example, is that you have a function that multiplies by 9. So if you pass 9 by times 9, at the beginning it will compute and they say, okay, this is 81. And then you store that result. So the next time, instead of actually you having to compute that, you just only output the result. So that's the idea behind this, and this is something very interesting concept because it was defined by Donald Michie, a AI and software engineering during the Second World War. That it now give us this technique from the mathematics to the computer science. That's great. That's powerful. And the other is once. So hey, you just only run this function once. So this is what closures allow you. And the other is that the way of how can we now identify at which line of code we are currently at. The call stack allows you to do that. So these features that I mentioned is what makes the JavaScript fundamentals. And then when it comes to deal with this async nature of how can we now do tasks that will be performed sometimes in the future, either will be resolved or rejected, how can we do that? So because JavaScript is this single thread application, is a single thread language, it doesn't deal with any of these async operations. So it's going to depend on vacate functions. And in the context of the browser, we have is set timeout, which is one of them, as a way to deal with this nature of or this async nature when we pass a function or a function reference to this vacate function set timeout, which are not part of the JavaScript. They are in fact something that is exposed by the environment, whether it's a browser or the Node server, that once you pass that, this is the way of how JavaScript communicate to the outside world. Here with the set timeout. So the set timeout receives that function, and when that times out, now you may wonder how it communicates to the JavaScript world again. So the host, or in this case the browser or the Node, must deal with this mechanism, which is the callback queue. So in the callback queue is when it's going to add all of these functions, okay? And who is the responsible to know when these functions are timeout, communicate that and notify that to JavaScript? That's when the event loop kicks in. So the event loop, we're going to say, hey, do we have, or is our call stack empty? Yes, it is. All right. Then let me now take whatever we have in the callback queue, put it in the call stack, and let JavaScript evaluate that. So it will gonna do that per function execution context. And that's something important to also remember. So because perhaps that might go beyond the scope of the word, but that's exactly what is going to do that. So you might wonder, how can we make sure about what you're saying is true? Let's find out. So in our case, let me open here the Visual Studio Code quickly. I just want to write some couple of functions here, especially the function one, and say, hey, async one. Okay, I'm not that creative right now because I just want to is being more descriptive about what we're going to do, and that is function async one. Here we're going to define is some things here like console log. Hey, console. Okay. And here we're gonna say, hey, set timeout. That's right here. And here we're gonna pass this a callback here and say, hey, you know what? Console.log here is the callback. Call. Okay, and then we're gonna run is the function async 2. Okay, and to be more specific here, you want to say hey, console async 1. Okay, callback async 1. All right, pretty much the same thing here, which is this, but now we're gonna call this 2 and then 2, and right after that we're gonna say, hey, console log of this is hey console. All right, and I want to now also do something like this. Hey console in global, and this is hey callback async in global. Then right after that, I want you now to run is this. Say async 1 and then async 2. All right, and then based on this, which is actually is a good exercise by the way, so based on this code, I want to know which one of them will be called first. So if you analyze here the first sentence, first we are declaring is async function here, async 1 and async 2 on a global variable environment, and then we are now is calling that. So here it is creating is a brand new execution context. It's going to we're gonna pass this to 0, okay, as well as to 0 millisecond. That's right. Yep. And here we're saying it's like, hey, I want you to now pass this callback reference to and communicate that to the web browser, and then it's going to now run this. So this in theory is supposed to run like this. So it must be say, hey console 1 async. Okay, so you evaluate that, and then if that is done, then you're going to evaluate is this. Let me put it this way. So this is not being resolved. Okay, so we're gonna see to the next line, and that is async. Hey, is this function here that we're passing to the set timeout? It is good. So we're going to print this async too, and then we're going to now, after that, print the hey console async too. So this is what it's going to print first, and then this. Okay, and so far we have now two functions that has been added to the callback queue, and when that time is passed, and as we continue evaluating, we're adding another global console here to the callback queue, and then is when you're going to print the hey console in global. After that, okay, it should do as it follows. The callback is in 1, the 2, and the callback in the global. As you can see, this is exactly the order in which it runs. So it's quite predictable, you know, once you understand how this mechanism works. And the problem with this is that, as you can see, you have to define a lot of callback function, and the most nested, or the more your tasks depend on any other previous async task, you soon realize that actually is quite horrible to read. So JavaScript designers say, you know what, it'll be much better if we define a way to make that easy to read. That's what we have here now, is the promise. So with promise, okay, now we have this particular way of handling its async operations. So for example, and especially with this vacate function, which is something that we're going to do a lot, and that is the Jesus, and that is the fetch function, okay, which is a function that is building the browser, is not part of the JavaScript, and it returns a promise. And here promise, it represents the completion, it represents the result, whether it's complete or rejected of an async operation. So with promise, especially when you're using with fetch, something that we have here, when you're using with a fetch, what you're creating effectively here is a two-prong or two sides. So we are having is a 2 points here that is doing behind the scene. First, promise, when you define that here, it create by default is a placeholder object that will represent is the eventual completion, and then this object will have is the value, that will have is the value based on that async task, whether it is completed or rejected, and as well as the another object that is unfulfilled, which is this property is where you're going to pass all of the function reference that you want to concatenate all of the function reference that will be called when the value from the object promise get updated. And you may wonder, who is actually doing all of this mechanism? Who is actually updating that value? That's when the job queue kicks in, or aka the microtask, which means that that mechanism is being handled by the take a look at this. That handle is being handled, that mechanism is being handled by ECMAScript, the ECMA language specification. So that's handled by them. Let me take a look at the promise object here. Promise object here. Promise object here. Control abstraction here. Exactly. Control abstraction objects. Control abstraction object. So because now this is the mechanism of how it create that. Create built-in function here. This is trigger promise rejection, host and queue promise, and it was here. New promise reaction job. This is what is going to handle and how JavaScript is going to resolve this. And the other is a normal current new promise resolve tenable. Host call job callback, which is here. A host defined abstract operation host callback job callback takes argument job callback, a job callback record like this, a job callback record, which is a function object. As you can see, the function to invoke when the job is invoked, and the host defined field reserved for use by a host. That's one of the interesting here. At some point in the time when there is no running context in the agent for which the job is created, and that agent execution context stack is empty. Exactly, and that agent execution context stack is empty. That's why you need to be careful here, because the execution context stack is something that is created by not only the running program, but also functions can create that execution context as it is. Perform any host defined preparation step, invoke the job abstract closure, and perform any host cleanup step, after which the execution context must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. So it's only one task here, because after all, JavaScript is a single thread application, or the ECMAScript. Abstract closure must return a normal completion, implementing its own handling of error. So the way or the mechanism that now, when you're creating a promise, especially when you want to communicate to other computer using the fetch method that is provided you by the browser or by the node, the environment. So these case functions will going is to create a promise object, that this is placeholders that represent is the eventual completion or rejection of that async operations, which will create an object that will contain is the value that is going to put in there, as well as the unfulfilled. So when the value updates, which is that is the mechanism that is going to be handled by the host through the Microtask Queue, okay? And now is the event loop that's going to evaluate, hey, if the call stack is empty, yes it is. So now let me read whatever we have on the callback on the microtask, which is a task that is defined, that is reserved for promise, and then pass that to the call stack in JavaScript. So now it can evaluate that with the proper value that we're getting from the facade function. Once it fetched that data from Twitter, from X, or Spotify, or Get. So that's very, very, very interesting as a way to understand all of this inner
Everyone's thumbs out.
mechanism.
You lost me. I'm clear. I have clarifications. Everybody's thumbs out. Alex has a clarification. Ben's clear. Blessing's clear. Sean has a clarification. Mike has one. Brian's clear. Let's come to Alex.
Mm-hmm. Mm-hmm. So after evaluating what's happening after evaluating what's happening, after evaluating what's happening in the last, after evaluating all of that, here's when we get is this, which is on your screenshots. Mm-hmm. I think it's this one. There you got it, exactly. We got this. Mm-hmm. So right now what I'm gonna do is to take notes out of the course, okay? So yeah.
Alec.
To Alec apostrophe
C
S.
with this. Yeah.
Yeah, that's why I was saying Alex.
There we go. Yep.
And that's literally why I was saying, as I said, I thought, that's interesting. If you speak in the possessive sense for someone in Alec, it's ambiguous. Let's come to Alec's question.
Maybe we're going to get to this, but I guess I was just wondering if it's going to use the event loop.
Absolutely. It is, but in a really interesting way. Sean?
So my question was if the web browser feature directly sets the memory, or if it uses the event loop.
Sean?
So my question was if the web browser feature directly sets the memory, or if it uses the event loop.
That's a very good question. It certainly gives precedence to setting that. More interesting is going to be when does the function get triggered. So let's hold that question for now. Mike?
I was just wondering if future data represents the promise object that's getting value updated. Why do we use a const keyword?
For values, for primitive values, that means numbers, strings, true, false, booleans. If you're going to change their value in any way at all, you're changing their position in memory, so you're not allowed to do so. But objects and arrays, as long as you don't literally throw out the entire object, replace it with a brand new one, and just add properties to it, or add positions to an array, elements to an array, that's well within the rights of const. Const only says, do not throw me out completely, my data, and replace it with a brand new thing in memory. You're perfectly allowed to add new properties to it, update the values of properties, add new elements to an array. Does that make sense? And that's why we all default to const now for everything, unless it's a primitive value, where you know you want to change it from 3 to 4, in which case that's not allowed, or if you know you want to switch an object completely out in memory and say, thank you for that object, here's a brand new one, then you'll use let. But I don't know when you do that particularly, but you might. So it's pretty much default to const now. And that's a helpful way of making sure reassignments don't happen unintentionally.
Mm-hmm. So, mm-hmm. facts or QA. So why we use const? So this is to preserve the reference. This is to preserve the same reference, of an object as a way to not relocate the data in memory. So for objects that are constantly change, you might want to use let. But in this case,
Good side question. I don't know when you do that particularly, but you might. So it's pretty much default to const now. And that's a helpful way of making sure reassignments don't happen unintentionally.
exactly. So for this, it helps us to not. So it helps us to prevent.
A good side question. I don't know when you do that particularly, but you might. So it's pretty much default to const now. And that's a helpful way of making sure reassignments don't happen.
So it is helpful because it allows to not need to reassign value.
Unintentionally. Yes. But I don't know when you do that particularly, but you might. So it's pretty much default to const now. And that's a helpful way of making sure reassignments don't happen unintentionally.
So it is helpful because it doesn't allow to make reassignment unintentionally. Reassignment unintentionally.
A good side question. Okay, further thumbs that were medium. Ben was clear. Who else was medium thumb? Yes. Rick.
Very good. All right. So when the future data's value is set, and
Yep.
it calls the onFulfillment function.
Let's say it triggers the onFulfillment.
Okay,
Because
so that-
it doesn't. We're going to see in a moment.
Yep.
There's definitely some intermediate steps before it gets called.
So when it gets triggered, is that in JavaScript or is that part of the web browser?
It's in JavaScript. And that's perhaps why we're going to discover JavaScript handles how it gets triggered and therefore called in a slightly different way. You're teeing something up nicely there, Rick. So let's see. We need to know how our promise deferred functionality. Display is a promise deferred function, right? Display was deferred on a promise. It wasn't deferred by passing into a web browser feature and then passed back into JavaScript. It was deferred by a promise. How it gets back into JavaScript to be run.
Exactly.
Okay, so I don't know any other example of code in entire history that require 3 functions to be defined for us to understand it. So I apologize, but this is big. This is like the mega, everything coming together in async. It's messy, it's big, but we get this down, we have every last piece of async down. Okay, we're going to walk through it. It's going to defer functions using an old school callback input, the print hello pass a set timeout. Old school facade function. It's going to defer functionality using a new school, double pronged facade function, fetch. It's going to block our thread in native JavaScript. It's all going to come together to ask ourselves which deferred functionality executes first. Okay, here we go. Let's wipe this clean. Sean, line 1, what are we
Which is
doing?
the first
Find
functionality first?
display as a place in memory.
Okay.
Yeah, functionality, declared in memory. All right, excellent display. Thank you, Mike. Next.
Print hello function is defined.
Print hello function is defined. Thank you, Mike. All right, next, Michelle.
We define a function that, in a black box manner,
Yeah,
allows
oh,
it to-
nicely put.
Exactly.
in
Nicely
black box
put.
manner.
Nicely put. In the black manner.
Block for 300 milliseconds.
Nicely put.
We don't know how it's going to do it. Can you remind us just how it might? How might we block our main JavaScript thread from running any further code for 300 milliseconds?
For some nasty.
really nasty for loop.
Yeah, really long loop, exactly. Which maybe assigning stuff or whatever. It's going to take time. Excellent. Thank you, Michelle. Now we hit the
Some sort of
interesting- We've done our
nasty.
setup.
Long,
Now we hit things that get interesting.
sort of long.
Okay, do you have enough room here? Yeah, probably. Okay. Set time out is passed the entire print hello function definition.
as a reference.
And its additional argument, Michelle, is
0.
which represents
0 milliseconds.
right the 0 milliseconds after which we want print hello to call. Now we probably realize all that can mean is that's the minimum. We know it will not be called before then, but when it's allowed, or it is the amount of time our background web browser timer will run for. That's what we know it does.
Exactly. It is the time that the browser background timer. That's exactly what is doing the set timeout. It is a time that the set timeout. It is a time. It is a time that.
Lost.
Yeah, it is a time that the background timers will set up.
The entire for that function print hello is ever allowed back into JavaScript, but it could be quite a lot longer before it's allowed back in. But it'll be queued up ready to go after 0 milliseconds. It'll be sitting there waiting to go on the call stack after 0 milliseconds.
Exactly.
Okay. So what does set timeout do on that note? Nothing in JavaScript, but what does it do, Blessing, in the web browser?
It calls a fetch.
Oh, set timeout.
No.
Yeah. Oh, sorry. The web browser feature timer
Timer. Excellent. With the properties.
of the function to call on completion and the time before it calls it.
And then here is our timer being set up in the
Content
web browser
complete.
with 0 milliseconds. Is it at this moment, Blessing? Is it complete?
No.
Is it complete? It's 0 millisecond timer.
Yes, it is.
So it's complete already. Excellent. And on completion, what do we say we want to do, Blessing?
Once
We're gonna
the
add
function and the callback.
that function,
Very, very good precision there by Blessing. We want to add print hello function to the callback
the
queue.
callback queue.
So let's do that. Let's put the callback. Let's put the callback queue. Callback queue. There it is. And actually, print hello is ready to go on there right now. It's ready to go and be added. So the event loop is going to be checking already. Can I add this stuff back to the call stack? Can I add this print hello function back to the call? It's sitting there ready to be run from basically, let's say this was 1 millisecond, basically from 1 millisecond. At 1 millisecond. It's sitting there basically from 1 millisecond in the callback queue, ready to be executed. It's complete. It's ready. It's past callback queue. It's ready to go back to the event loop. We're going back to the call stack, but the event loop is sitting there, and it's like a guard protecting. So, what
like
is
a
our
guard
next line of code? Because print hello is ready to run. Can it run though?
No.
Because what's my one simple rule for the event loop, Michelle?
The call stack.
The call stack must be empty.
It has to be totally clear, and all global code has to finish executing.
The call stack must be entirely empty.
So we are definitely not there yet. So instead, at 2 milliseconds, we hit what line, Michelle? Actually, Abdi, what line do we hit at 2 milliseconds? Excellent. Be careful saying variable. I think from now on, just say a constant future data. That makes sense. Or a const, yeah. Future data. Now, it's going to start off undefined, as anything that's right-hand side is unfinished work starts off undefined. It's got to go and figure out what that right-hand side is going to evaluate to. Evaluate is the posh word for get me down to my my value. This is a command. I can't store a command. I can't store a command to go and run a function. I can only store the returned value from that function. Okay, so let's start doing that. Future data.
So future data is going to evaluate,
the return
and
value
that is
in JavaScript,
the return value
of using
in
this
JavaScript
double-pronged facade function
of using
fetch
this.
that does something in JavaScript and also
Is using is this facade function called fetch,
in the web browser features.
and then it's going to
themselves.
communicate
But it
to
does
the
do something in
browser.
JavaScript as well this time. And what is the thing that it does in JavaScript, Abdi?
It creates an object with value and unfulfillment.
Excellent, man. Yeah.
So this promise it will create is now a value object. You're going to create an object will contain a value as well as a reference. That's another. But first, it's going to create is a value with the value key with the value right now, or the argument empty right now, and then the unfulfill.
It returns out an object with a property.
But it
value
also
undefined,
has
on
on
fulfillment that's an
reject
empty
as well.
array into which we want to push all functions that will be auto-triggered when value gets updated. And this returned out JavaScript object is the output of running fetch. This is what comes out. It's returned, and therefore it is assigned to future data. Okay, so there's future data is now that returned out promise object. There it is with value. We're almost there, people. On fulfillment is an empty array that will be triggered to run all its functions when value gets updated by fetch's web browser work. So let's talk about web browser work. What is the consequence who am I going to call on? Victor. What does fetches in its sort of facade function form? What's the thing it does in the web browser in addition to this object it returns out in JavaScript? What's it set up in the web browser, fetch?
Is now passing is a proper is passing is the argument. Enough, man.
Man, yeah. It returns out an object with a property the path and the method. It auto defaults to get, and that is going to send off in the web browser. Everything in blue is the web browser. That's going to send off to Twitter.
So you're going to send that communication to that, and once that is complete,
and we're going to hopefully get some data back. Is it complete, Brian, at 2 milliseconds?
No.
Definitely not. But on completion, what do we want it to do? Brian, do you know what we want it to do on completion?
We want to assign the value.
We want to send the value. We want to assign the value that we get. We're going to assign the value from the data that we get back from Twitter.
Excellent.
Value.
On what object?
Future data.
Very well put,
On
Brian.
the future data.
Dot value will be whatever comes back from this background work. Well done, Brian. Okay, so Fetch's work is done. Fetch is the most complex one-word API I've ever seen. It's literally two-pronged. It does something in JavaScript, something in the web browser. That is why it's ridiculous. Okay, but now we continue on in JavaScript. So immediately after we've done future data equals return value of fetch, which is object, future data, promise object. What's the next line of code we hit, Mike?
The future data dot then.
Exactly, the future data dot then, which is not running, which is a misinterpretation of the done, and that's one of the things that the dot then is actually quite. This is a wrong name. To me, this is a wrong name because you can read that it actually feels that, and you can think that the future data dot then is when you're gonna run that data, and that's not what happened. What you're doing is that when the data gets updated, this is the reference, or this is the unfulfilled functions that we want to run. And we can also concatenate also other unfulfilled functions.
Excellent. Future data dot then passing the
So
display the entire
it's
definition.
just concatenated. It's just adding this callback
being
functions.
passed to the then, which we're actually going to replace the then method with. Store this function on this object future data.
Store this object function on,
to be triggered when value
is updated.
That's what then is doing. Imagine it's called that. It is being done right now. Its only job, and it is
because it's like that. It's taking it as a callback. And as you can see here, we can see unfulfill a function to asynchronously execute when this promise becomes fulfilled. It is returning value because the fulfilled value promise returned by .then. The function is called with the following argument, value. The value that the promise was fulfilled. If it is not a function, it is internally replaced with an identity function like this. Simply pass the fulfillment value forward. So you're gonna get is the value for that, okay? And on reject, you're gonna get is the reason for that. Return value, return a new promise immediately. Object. This new promise is always pending when returning, regardless of the current promise status. By default, you always return a promise as a pending value. One of the unfulfilled and unreject handlers will be executed to handle the current promise fulfilled on rejection. The call always happens asynchronously, even when the current promise is already settled. The behavior of the returning promise, called P, depends on the handler's execution results. Following a specific set of rules, if the handler function returns a value P, B gets fulfills with the return value as it is value, doesn't return anything, throw an error, return an already fulfilled promise, B gets fulfilled with the promise value as it is value, and returns an already rejected promise, or return another promise, return another pending promise. This is what are the things that it can return. Right now you're not able to see that, but it's this. And the dot then. So unfulfilled, you're gonna get now as the value of that, or the reason. A function to asynchronously execute this promise becomes fulfilled. And this is the set of rules here. If the handler function. There are tenable objects that arise along the chains and are always resolved. Exactly. So when this is available, the question is that, okay, so now that we know this object that it's always returning by default is pending, how can we get that data, or how can we access to that data? You know, how can we access to that data? That's quite interesting.
It's never going to be done doing anything again. Its only job has one other job, but its only interesting job for us right now is getting that function stored on future data. Under its what array, Ben?
On fulfillment.
Right, it's hidden on fulfillment array. That's where it's going to be stored, which is its hidden on fulfillment array. And so we are going to put the display function, or at least a reference to it, a link to it, in the on fulfillment array. There it is. Okay, good. By the way, all through this, print hello is still sitting there saying, can I come back on the callback queue? Callback's called, whatever it's called, call stack, whatever that thing's called. Precision. Back on the call stack, and the event loop's going, not allowed back on yet. But maybe now it's allowed back on, because we've done that. No. What's actually our next line of code, Abdi?
Console login, me first.
Oh, we got one before that, dude, just after the then.
Oh, sorry, I didn't see that. We're running the function block for 300 milliseconds.
Block for 300 milliseconds, whose functionality we don't know how it's working. We just know that it's going to sit on our call stack. We're going to enter it. We're going to sit there for 300 milliseconds and come back out only at 303 milliseconds. Okay. Well, while it was on the call stack, let's actually put it on the call stack so it's really clear. While it's on the call stack, block for 300 milliseconds, while it's on the call stack, what happens? Well, actually, our request comes back. So at something like, I don't know, let's say 290 milliseconds, our request comes back, and Ben, what's our very nicely structured data we get back?
Response data. Hi.
Right, hi, exactly, hi. We're going to simplify here slightly. There it is, hi. And what at that point is it going to trigger to update?
Future data dot value.
Excellent, there it is, which is going to trigger this little guy here, display function.
This display function, exactly.
So at this point, while we're inside our block for one second, while it's on top of our call stack, we have ready to go print hello. We've known that for a long time. We now have ready to go display. So we don't call display. Where do we think we pass display, Ben? Michelle, where do we think we're not going to call display immediately? Where's it going to go? We're going to put it on the callback queue. Or are we? Yeah, there it is. For now, there, good. Display on the callback queue. Sounds good to me. And it gets added there at about, what, 290 milliseconds. The people who stop watching the video right now, they're getting falsehoods. But there we go. There it is, nice on the callback queue. Hooray, excellent. Block for 1 second finishes running, so it's for 300 milliseconds, finishes running. We come back out of it at, I don't know, 303 milliseconds. And we have teed up to go. Display. Actually, I can't do this. We have teed up to go. Display. We have teed up to go. Print hello. We have teed up to go. What's our next synchronous line of code, Brian?
First,
Cool. Which one's going to go first? Okay, I think the first one we know which one's going to go first. Which one's going to go first? Me first. Yeah, we got that bit. Like, synchronous code is above. It is the monarch. No, that's not. It doesn't make any sense. It is the. I don't like that. I don't like that sort of stuff. Someone asked me during a talk on Sunday or Saturday, why are you not talking about the royal wedding? I left this country. I do for a reason. All right. Okay. Although I did go and watch the pictures, like sort of sneakily watch the pictures and pretend it didn't affect my sense of views in meritocracy. All right. So me first at about 303 milliseconds. 303 milliseconds. We get me first. Can I just first note, by the way, that we deferred print hello at 0 milliseconds, or whatever it was, 1 millisecond. And for 0 milliseconds, and it still has not been allowed to run. We then deferred our display function to be run, triggered to be run when our data came back, and even though it's been ready to go for like 10 milliseconds at this point, it's still not allowed to run. When we exit block for 300 milliseconds, we still hit the console log first, the synchronous code first. We knew that bit. Now is where it gets really interesting. Now is where it gets really interesting. We have two, our event loop, at least now, is like, it's happy. All the global code's finished running. Now it's ready to start running stuff in the queue. We have print hello ready to go. It's been in the queue for a long time. And we have display ready to go. It's just enter the queue 10 seconds, 10 milliseconds ago. It's good to go now. It took a bit of time to get back, but now it's good to go. Which one is going to go first? Well, we've already said, this has been in the queue. How do queues work, Alec? Yeah, we're going to add
stacks.
display in the back of it, right? No, not like stacks, Alec. Very good, very funny, very good. It's not going to be, it's going to be added to the end of the queue. It's going to be the last thing, is the last thing added to the last thing out. First in, first out. So next in, who thinks next in line is print hello? Raise hand high if it's print hello. I know I'm doing my, it's not the right answer voice, but come on. Give me another explanation why. But you're right. Well, no, the three of you raise your hands are wrong, but thank you. Because everyone else thinks that, but they know they heard the voice. It's the wrong answer voice. And so they refuse to, they don't want to get the wrong answer. Embrace it. Okay, yeah. Turns out JavaScript has an additional queue. It has an additional queue.
ECMAScript has an additional queue.
People should be talking about this queue. This queue is an additional queue. It's called the
Job
Microtask.
queue.
And the actual JavaScript spec itself calls it the job queue.
Exactly.
The Microtask queue.
The job
where
spec,
any
exactly.
functions that weren't deferred using this traditional model where I set up a web browser task and use a web browser feature timer, for example, and don't return anything into JavaScript, no placeholder object, that function gets triggered directly from the web browser feature completion. It gets pushed to the callback queue. But I now have a new way of teeing up background work. These new types of web browser feature APIs or facade functions. Ones like fetch. They return out an object, a promise object, into JavaScript. Their value gets updated from the background web browser feature, and it triggers in JavaScript the function display. And that triggered function is not ending up.
Not at all, bro. Job queue. This was in 2016, and now they have updated the language, bro. In the job queue, job and house operation, job and job queues. Syntax directions. Executable code and execution context. Executable code and execution context. But that shit doesn't work. Executable code and execution context. Yep, executable code and execution context. Job queue. Execution context here. And now in the newer version they put in here. Agents, job and house operations to enqueue jobs. Jobs and job queue. Which is pretty much that. And there is when he's going to explain a little bit that. Job arguments rel, script or model, host define. Anyway. Move on here.
Only job, and it's never going to be done doing it again. Its only job has one other job, but it's only interesting. Print hello. We've known that for a long. We have to go. What's our next synchronous line of code, Brian?
First,
Hold on, which one's going to go first? 303. And even though it's been ready to queue for a long time, it's going to be a traditional model where I set up a web browser task and use a web browser feature timer, for example, and don't return anything to JavaScript, no placeholder object. That function gets triggered directly from the web browser feature completion. It gets pushed to the callback queue. But I now have a new way of teeing up background work. These new types of web browser
have a new way to
feature
team up.
APIs or facade functions.
I have a new way to team up this.
Ones like fetch, they return out an object, a promise object, into JavaScript. Their value gets updated from the background web browser feature, and it triggers in JavaScript the function display. And that triggered function is not ending up on the callback queue. It's getting passed to the Microtask queue. Display passed to the Microtask queue. At, 290 milliseconds, fine. Much later. But the event loop prioritizes tasks in the Microtask queue. And so what happens here? Yes, now we've finished our console log. The event loop goes, hooray, the call stack's empty, global code execution is finished. I'm going to go and check, not my callback queue first, but my Microtask queue. What do I find there? The recently added display function. What I do with it, I put it on the top of my call stack, with its argument being the value that triggered it to run. And so into my display function goes my argument hi. And so at about 304 milliseconds, I'm going to finally call, or not finally, I guess, fairly quickly call display
Fairly
with
quickly
hi.
called here.
And that's going to
display hi.
do what in my console, Michelle? What's display? Its input gets what?
Console the data that we're passing down to. Stop it. Where is
Happens
it?
here? Yes, now we've finished our console log. The event loop goes, hooray, the call stack's empty, global code execution high. And so it takes in the future data value, which was high because that future data value was triggered by this background work, which then triggered the display function to run with that value as its argument. Very good. And then there it is at 304 milliseconds. We are going to trigger, or sorry, we are going to console log high. Then, I forgot to say, we therefore dequeued this task. When we took it to the call stack, we've now finished it on the call stack. The event loop's doing its spinning, saying it's a call stack empty, it's empty again. Microtask queue, it's empty. Callback queue, got something in it. Finally, our poor little print hello that's been delayed for so long. This little guy's been sitting there since 1 millisecond. Finally, poor print hello at 305 milliseconds is allowed onto the call stack. And there it is, print hello added to the call stack at 305 milliseconds. We get hello. Despite it being the first thing to be teed up, the first thing to be kicked off to be deferred, before we deferred our display functionality to display our tweet when it came back, before we set up our console log me first, it was not allowed back onto the call stack, DQ'd from the callback queue now, wasn't allowed back onto the call stack or allowed into the call stack until all synchronous code was finished running. And until we'd cleared our Microtask queue as well. This, folk, is all of asynchronous JavaScript. Every last piece. Let's have thumbs on it. You lost me long ago. This was a mistake coming in today. I'm clear. I have clarifications. Everybody.
There's a mistake coming today.
Michelle has one. Alec has one. Paul has one. Paul, you kick us off.
I'm just curious if there are any common browser methods or others that drop to the Microtask queue instead of the callback queue.
Oh, so there are. So you can go and look up. The way you find it out, you go to the JavaScript spec. Because actually, MDN doesn't say. I don't think. You go to the JavaScript spec and you see where does it go, which queue does it go to. It'll say certain tasks, like I believe event DOM changes, DOM manipulation changes. I believe you have to check this yourself. Go to the job queue. So it'll say in the spec. The next the task triggered by the DOM manipulation is in the job queue. Whenever you see job queue, it means Microtask queue. Versus task queue, which is typical of the term in the spec they use for the callback queue. So you can see on a feature by feature basis in the spec which one it gets sent to. And by the way, it's a spec. Specs are we may or may not implement this way. So for a long time,
specs are we may or we may not implement this way.
Browsers other than Chrome through promised deferred functionality not on the Microtask queue. They put it on the back of the callback queue. This is a spec. A spec is like this is how it should be implemented. It's up to you. Now I'm pretty sure they all implement it the same way with the Microtask queue, but it's not by default. Like it's not like that is how the world must. That is just guidance by the designers of JavaScript.
Exactly.
Kind of crazy.
This
But
guidance.
now you know why it, behind the scenes is these two things that might be in conflict. One comes first or the other in different browsers. All right. Great question, Paul. Very nice. Was it? Who else had a clarification? Michelle.
That was a very, very interesting question, because after all, since all of these are facade functions, especially when you want to interact with the DOM, which queue is actually, who is actually deferring all of this task here? You know, it's like the DOM on the ECMAScript, okay? Because DOM queue, you know, who is using that? Queue. In the microtask and the JavaScript runtimes environment. Task and microtask. Task. A task is any JavaScript code which is scheduled to be run by the standard mechanisms such as initially starting to run a program, an event callback being run, or interval timeout fire. These are all get scheduled on the task queue. For example, a new JavaScript program or subprogram is executed, such as a code from console or by running the code in a script element. An event fires an event fire is handling in the task queue, which is in the callback queue. Adding the events callback queue functions to the task queue. A timeout or interval created by set timeout or interval here. Interesting. The event loops driving your code handles these tasks one after another. In other words, in which they were in queue. Right now you're not able to see what I'm doing or what I'm looking at right now. But it's like, okay, because now this is the async nature of JavaScript. And especially if you want to talk to any specifically features that are outside of JavaScript. So we want the environment, in this case, maybe the browser or the node, expose these facade functions so you can interact to do some async operations, whether it is by firing events, done operations, fetch, animations, right? So in our case here, look at this, JavaScript promise and the mutation observer API both use the Microtask Queue to run callbacks, which is, it has a much priority here. Promise and mutation observer API. But there are other times when the ability to defer work until the current event loop passes wrapping is helpful. In order to allow microtasks to be used by third-party libraries, frameworks, and polyfill, the QMicrotask method is exposed on the window and worker instance. This is a way of how you can defer task here. Okay, and have a higher priority with the microtask queue. So the event loop here, the oldest runnable task in the task queue will be executed during a single iteration of the event loop. After that, microtask will be executed until the microtask queue is empty. Okay, after that, microtask will be executed until the microtask queue is empty. And then the browser may choose to update rendering. Then the browser moves to the next iteration on the event loop. The event loop driving your code handles these tasks one after the other, in the order in which they are in queue. The oldest runnable task in the task queue will be executed during a single iteration of the event loop. So the oldest one, which means is the first one in the queue. The oldest runnable task in the task queue will be executed during a single iteration of the event loop. After that, Microtask will be executing until the Microtask queue is empty. And then the browser may choose to update re-rendering. Then the browser moves on to the next iteration of the event loop. Microtask. At first, the difference between microtask and task seems minor, and they are similar, both made of JavaScript code which gets placed on a queue and run at appropriate time. However, whereas the event loop runs only the task present on the queue when the iteration begins, one after another, it handles the microtask queue very differently. There are two key differences. First, each time a task exits, the event loop checks to see if the task is returning control to the JavaScript code. If it's not, it runs all the microtasks in the microtask queue. The microtask queue is then processed multiple times per iteration of the event loop, including after handling events and other callbacks. Second, if a microtask adds more microtasks to the queue by calling queue microtask, those newly added microtasks execute before the next task is run. That's because the event loop will keep calling microtasks until there are none left in the queue, even if it's more keep getting added. Those newly added microtasks execute before the next task is run. God damn it. Since microtasks can themselves enqueue more microtasks and the event loop continue processing microtasks until the queue is empty, there is a real risk of getting the event loop endlessly processing microtasks. Be cautious with how you go about recursively adding microtasks. Interesting. Using microtasks. Before getting further into this, it is important to know again that most developers won't use microtasks much, if at all. They are a highly specialized feature of modern browser-based JavaScript development, allowing you to schedule code to jump in front of other things in the long set of things waiting to happen on the user computer. Abusing this capability will lead to performance problems, of course. When to use microtasks? The main reason to use microtasks is that to ensure consistency ordering of tasks, even when the result or data is available synchronously, but while simultaneously reducing the risk of user discernible delays in operation. This is data dispatch, and then you dispatch an event that this dispatch event will be added in the task. Okay. Otherwise, the prototype get data. So you set the data that you're getting from that to set the catch here for whatever object you get here, the custom element here. Okay. And then you're going here have an event you're going to add to this custom element, the dispatch, or you're going to access to that and say new event load. Otherwise, you're going to now run the fetch function, and then when that data is returned, when that value is updated from these async operations, if that value gets updated, you're gonna now run this unfulfilled, which is the result that you get from here. And you're going to now change that or make it tenable, okay? Which means that, well, the result from this will be now the input from this new function that we want to run, where we contain the data, and then we're gonna do is this. The problem introduced here is that by using a test in one branch of the if-else, which is this, in the case in which the image is available in the catch, but having promise involved in the else clause, we have a situation in which the order of operation can vary. For example, as seen below. Hey, I want you to now load this or run this. Exactly on the element, add event listener load, console.log fetching data, element that get data. Data fetched. Executing this code twice in a row gives the following result. Because you're adding now an event listener here, this is now interacting is with the DOM. So it print this, it's supposed to print this, okay. And now who's gonna get first? This one, since you are now dealing is on the Microtask, and the get data, it'll be this. Loaded data. When the data is not catch, loaded data. Okay, dispatch this event. Exactly, loaded data. When the data is not catch, when the data is not catch, dispatch the event. When the data is catch, you're gonna get that data. Fetching data, load data, okay, and then data fetch. Even worse, sometimes the element data property will be set on other times. So this balance the clause by having both situations handle the setting data here by the queue Microtask here and batching operations. This is a way of how you can defer a task to that. Log before executing this Microtask. Okay. After executing the Microtask, and then by passing queue Microtask log, the Microtask has run. Timeout of Microtask example. As soon as possible. Callback and urgent callback. Main program started, set time and callback, regular callback, queue, an urgent callback here, log main program. So this will be called after this, exactly, oh no, this, and then a regular callback. Note that the output logged from the main program body appears first. Exactly. followed by the output from the microtask, followed by the times up callback. That's because when the task that's handling the execution of the main program exists, the microtask queue gets processed before the task queue on which the times callback is located. Remembering the tasks and microtasks are kept on separate queues, and the microtask run first will help keep this straight. Microtask from a function. Oh, interesting. Then do the work function here calls crew microtask. So main program, you're gonna call this set timeout. You're gonna pass a callback to the set timeout, and you say log 10 equals do work, and then log main program. So do work will be called here, and it's going to evaluate this. Queue microtask urgent callback here, and then runs this. You're going to return is the operation here, which is things equal 10 result times the I, and then you're going to assign that 1 things equal to that exactly this one. So I want you to evaluate that first, which is this, the result here, and then bring the main program exited, and then do is this, evaluate this microtask here, and then the regular callback. Graceful asynchronous programming with promise. Using the fetch API. Catching errors. Combining multiple promise. And then async and await. Okay, that's quite interesting. generate a code for a controller. Yeah, generate a code for a controller capable to handle multiple requests capable of handling 4 multiple requests all at once and provide error handling if each one of them fail. I get it, because we all settle. So hey, all of these asynchronous tasks, each one of them fail. Okay, if one of those tasks fail, abort the operation. But that sometimes can lead to unwanted state. That's where we have all settle. It's like, hey, is everything went well, or is let's going to prepare everything to make that happen.
So when future data.value gets set, it kind of seems like that escaped all of the handling in the stack and everything, and it's just kind of magically done almost instantaneously on complete.
Yeah.
Are we missing a step there, or is it magic?
Everything that you do is being handled in an event loop, but we can assume in that case that it's giving absolute priority because it is done before any of this function execution work. So the thing that would block our functionality being updated. So this value here has no interest except in the functionality it's kicking off. So for our purposes, all that matters is the functionality being kicked off. So this always takes precedence, as far as I can tell, over anything that would lead us to be surprised the display is being delayed running. So just to be one final thing, the only bottleneck on display running is our event loop prioritizing synchronous code, not something else. So the value being the block on running, I can't see any evidence that would ever be the block. So we don't need to worry about when it gets updated. It's always going to take precedence. Okay.
So
as far as I can tell,
it's not so much that if you were able to somehow magically preempt in your global context and call value that you would have it, but that value is made available to onFulfill at that point.
Correct. And actually, just this morning I was always going to take precedence. Okay.
So so when future data.value gets set, it kind of seems like that escaped all of the handling in the stack and everything, and it's just kind of magically done almost instantaneously on complete.
Yeah.
Are we missing a step there, or is it magic?
Everything that you do is being handled in an event loop, but we can assume in that case that it's giving absolute priority because it is done before any of this function execution work. So the thing that would block our functionality being updated. So this value here has no interest except in the functionality it's kicking off. So for our purposes, all that matters is what is the functionality being kicked off. So this always takes precedence, as far as I can tell, over anything that would lead us to be surprised the display is being delayed running. So just one final thing to show. The only bottleneck on display running is our event loop prioritizing synchronous code, not something else. So the value being the block on running, I can't see any evidence that would ever be the block. So we don't need to worry about when it gets updated. It's always going to take precedence. Okay.
So
as far as I can tell,
it's not so much that if you were able to somehow magically preempt in your global context and call value that you would have it, but that value is made available to onFulfill at that point.
Correct. And actually,
context and call value that you would have it, but that value is made available to onFulfill at that point.
Correct. And actually, just this morning I was testing whether you can view value earlier, and so I think values assignment still happens after all of the call stack work is done. So it's at the end of the event loop cycle. In other words, the event loop is going to always grab all of the call stack, always going to do all the synchronous code first before it updates value. But that has no implications because it's never going to trigger a function anyway until all that work's done. So if that happens at the very end and then it triggers a function, we know the function's never going to be triggered until that point anyway, so who cares when value gets updated? Okay. There was one other one, Rick? Was it? Oh, it was Alex. Sorry, Alec.
Yeah, I think it's kind of similar to that last question. I was wondering if the onFulfill functions get added to the Microtask queue, and then value is updated in the meantime. Like, I'm not sure if that
what
would
an
ever
interesting
happen.
question. The Microtask queue, that's an interesting question. The Microtask queue is designed that the event loop doesn't leave it until it's finished all tasks in it. Meaning, by the way, if you had inside display an auto-resolved promise that would instantly trigger a function to be passed to the Microtask queue, to be clear on that, the promise object was auto-complete, auto had its value, and therefore triggered the on-fulfillment function, or the functions in on-fulfillment, they would be added straight to the Microtask queue. The event loop would never leave the Microtask queue. It would never actually reach the callback queue again. You can starve the callback queue. That means prevent the callback queue's functions from running by the Microtask queue by its design. The Microtask queue is designed that when the event loop is grabbing things from it, as long as there's something in there, it ain't leaving, even if you're adding more as you go.
It ain't leaving.
Think of it as an infinite while loop on picking out tasks from the Microtask queue. It's very, very interesting. I want to add a few extra conditions to this. Everybody who knows promises knows there's another property on here called status. It has 3 values it can be.
Reset.
Pending,
Resolved, and
rejected. Okay?
Exactly.
It defaults to pending when we first return out the object. That just means I don't yet have a value in value.
So by default, it returning is the pending. So I don't have any value right now, so it's pending. It's pending. It's pending.
Correct. And actually, just this morning, I was testing whether you can view promise object auto-complete, auto had its value, Microtask queue. It's very, very interesting. I want to add a few extra conditions to this. That just means I don't yet have a value in value. I don't yet have a thing stored in value. My background work's nowhere near done yet. When this background work successfully responds, that status property, we can even write it in, that status property, and this is a visible property, that status property becomes resolved. And actually it's that triggers the on-fulfillment array of functions to run with this value. But, whatever. There's another output the status can get, which is rejected. Rejected is when there's some error in the background work, something errored. Maybe the server's status came back with an error, you didn't get a successful response. And that's not going to trigger an on-fulfillment array of functions. It's going to trigger a different array of functions on rejection.
On rejection.
And those functions, how do we get functions in there? That array, how do we get functions in there? Correct. We pass them to future data, not .then, but .catch.
.catch.
And the function we pass to .catch will be stored in the
Will be
on-rejection
stored down
array.
on rejection array.
Have be triggered there. We can also pass it as the second function to then. Pass in here, like, I don't know, error function. And that will be passed not to on-fulfillment, but to a different array of functions in here called on-rejection. And so if we get an error in any of this process, it will not trigger display. Instead, it will trigger the array of functions known as the on-rejection array. Good. So we have this new model for thinking about how our JavaScript executes. We are not alone anymore asynchronous language. We're a language that actually has asynchronicity built into it through the Microtask queue, and in terms of how it interfaces with things outside of it as well, it has a ton of asynchronous features available to it in the web browser. Excellent. So what is our problems with our final, or our solution 3 here, the promise-based model? 99% of developers have no idea how these promise objects are working under the hood. They see .then, and they go, my thread will return back up to there when future data gets filled in, and then call display. So far from the truth. Instead, the then, its only job or of interest here is to grab our display function and put in future data's hidden on fulfillment property, an array. Debugging becomes super hard if you do not understand how this
Exactly. So you're gonna detect that. You're gonna. So whatever callback function that you pass into .then, it will assign that and it will pass that to the unfulfillment, which means that based on the object promise that has is the value that will be updated by the browser. Once that happens, okay, then it's going to now add that function to the Microtask queue, okay, to actually evaluate that in the call stack in the JavaScript world. So the .then, whatever callback function that you pass there, it will get triggered on fulfill. It will get triggers when the value get updates and you have something that you pass to the unfulfilled array. And in the case of the catch, it will say, hey, this is the callback function that I want you to pass down when unrejected promise is being done.
Happening under the hood, and unlike traditional asynchronous work, at least there you knew it was weird. Here it looks a little bit more meaningful. It masks the complexity. But benefits, you understand it, you get a cleaner, readable style with pseudo-synchronous code. These then methods being called give you a pseudo-synchronous style, and it has a really nice error handling process. It's a really nice error handling process to be able to pass a second function, that's your error handler function, to be able to call .catch to add more error handling functions, or an alternative way about handling errors. That's a really, really nice benefit of this model. And we're going to see our final version at the very end of today, async await, doesn't give you as pretty a way of handling errors, actually. It's in theory a step back, I guess. Not. I would say step back from this very clean error handling way. Not step back, but there's a way of handling errors which is perfectly fine, but this kind of like, I have my error handling function and I have my regular success function. That's pretty nice. That's a pretty nice model. All right, good. So, promises, web APIs, the callback, microtask queue, event loop, allow us to defer our actions until the work, the background heavy lifting work, the long time work, the slow work is completed, and continue running our code line by line in the meantime. Asynchronous JavaScript is the backbone of the modern web, letting us build fast, non-blocking, we flow on.
Exactly. Asynchronous function is one of the backbone of the modern web, letting us build fast, non-blocking
while we let our
applications.
Web browser features do the slow work, non-blocking applications. All right, beautiful.
That's quite interesting and powerful.
Now, we move on to iterators. Okay, iterators. Iterate.
That's one of the reasons why a lot of these people actually here is they're doing so promise.all settle. This return promise fulfilled when all the input promise settle, including when an empty iterable is passed, with an array of objects that describe the outcome of each promise. Even if they are fulfilled or rejected. Promise 1 resolve. Promise 2 is going to reject that. Already fulfill, asynchronous fulfill. And then you get that all. Exactly. If any of the promise down there fails, okay, it'll return that. So for example here, if I use it, so promise.all static method takes an iterable of promise as input and return a single promise. And in return, it's a single promise, an object here. This return promise fulfill when all of the input promise fulfill. Exactly. This return promise fulfill when all the input promise fulfill, including when an empty iterable is passed, with an array of fulfillment values. When like this, the return promise fulfills. It returns a single object. This return promise fulfill when all the input promise settle, including when passing iterate, with an array of objects that describe the outcome of each promise. But in this case, the return promise fulfill when all of the input promise fulfill. All of the input promise fulfill and settle. That's different. That's different. Fulfill. Method is one of the promise concurrency method. It can be useful for aggregating the result of multiple promises. It is typically used when there are multiple related asynchronous tasks that overall code relies on to work successfully. So promise.all would reject immediately upon any of the input promise rejecting. Exactly. It will reject immediately upon any input promise rejecting in comparison to the promise return that all settle. Will wait for all input promise to complete. The difference between all and the all settle is that promise all settle will wait for all the promise to complete, regardless of its states, and the dot all is gonna wait for all the, or it will reject immediately upon any of the promise rejecting. Otherwise, it will return their value. Use all settle if you need the final result of every promise in the input iterable. If you need the final, if you need the final result of every promise. So, hey, do we create a service? Imagine that you're talking to several servers down there, okay? If any of them fails, do not attempt to do that. In fact, asynchronicity and synchronous or synchronicity of promise. The problem with this is that it will. So let me actually do this here. For example, here, promise.result 33, promise.reject 34. And set timeout. Logs, promise, stay pending. The queue now is empty. Okay. And then promise, state rejected, and reason 44. It's because this is what it's going to return here. It returned this object. Promise.all with async functions. Or something like, so what you're gonna get is the value, the eventual completion of each one of them. Because error handling is intuitive. If any of the promise rejected, the result is no longer available. So the whole away expression throws. Promise.all accept an iterable of promise. So if you're using it to run several async functions concurrently, you need to call the async functions and use the return promise directly. Passing the function to promise.all does not work since they are not promise. Of course. Fail fast behavior. If it is possible to change this behavior by handling possible rejection. So for example here, if I put it this way, but here I'm saying is something like reject. Come on, man. Ah, flying fuck. Okay, reject here. Rejected. Exactly, and in return is that. In return is rejected. It returns a promise object that will contain is the state and the reason, followed by the prototype. Because at the end of the day, promise is an object function combo. To an object, to a null. But exactly, if any of them fail, it will return a promise object here. The problem with that is it doesn't tell you which one of them fail. You know what I mean? It doesn't tell you which one of them fails. Exactly, it doesn't tell you which one of them fail. Whereas here, it is telling you, hey, of course, no. And here you're gonna get all the data there. Exactly. In fact, it's returning not only the values, but also is the pending promise object here, where the value undefined, okay, initially, and then if everything went well, good. But the problem is that if one of them fail, okay, if one of them fail, you don't know why was that. But here it's telling you, hey, this promise was fulfilled, this promise was fulfilled, but this was rejected, you know? But this was rejected. So if one of them, if one of those embers lets alive, a fire will break out through soon. So the idea of the, okay, so so knowing is the promise that all and promise that all settle, is that promise that all, it will get you, so it will run all of the promise if they are fulfilled and they give you the result. The problem is that if one of them fail, it will give you is a promise object with the fail, but it doesn't tell you which one of them fail. Whereas with promise all settled, it gives you all of this promise status, and you can have much more fine control about which one of them fails or not. That makes ton of sense, and especially if you want to do now transactions, okay, when you want to when you want to be sure that all of this series of async tasks are successfully done. All right, and if one of them fail, you want is to go back. You want to roll back that transaction. That makes a lot of sense. That makes a tons of sense. Okay. Yeah. That makes a tons of sense. Roll back the operation. It's not giving you the proper outcome here. Object.value seems after all is returning is okay. Object.values of the result is some of the results are different from null. Okay, check if any promise fail. Check if any promise fail with object.value. Hey, from this array of objects, I want to see if any of them fail. But for that, you should make sure that it's from all settle. That's another way to put it. That's another way to iterate through that. If any one of them fail, I want you to roll back the operation. Exactly, perform a rollback. That's quite interesting here. That's quite very, very, very interesting topic here that we are talking, because this is now promise queue, promise and microtask queue. Promise and microtask queue. Okay, that's quite interesting. That's very, 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 very interesting. That's very, very, very interesting. That's quite interesting. Totally interesting here. So promise and microtask queue. So by now, looking at, okay, and take a dive deep into this. And the dive deep is also by looking at promise object, okay, that it has the pending, fulfill, and rejected, okay. It has all of these 3 states, okay. This let asynchronous method return values like synchronous methods instead of immediately return the final value. The synchronous method returns a promise to supply the value at some point in the future. So this is how you can do this. The promise is already resolved at the time when it is created because the resolver order is called synchronously, but is resolved with another promise and therefore won't be fulfilled until 1 second later when the inner promise fulfilled. In practice, the resolution is often done behind the scenes and not observable, and it is fulfillment or rejection are. As only it is fulfillment or rejection are. Several other languages have mechanisms for lazy evaluation and deferring a computation, which is kind of the thing what we're doing. Lazy evaluation or deferring a computation, which they are also called promise. Scheme, example scheme. Promise in JavaScript represent processes that are already happening, which can be changing with the callback function. If you are looking to lazy execute an expression, consider using a function with no arguments like this to create a lazy evaluated expression and F to evaluate the expression immediately. Lazy evaluation. Chaining promise. The promise that then catching finally. But the construction promise, what it returns exactly? It returns an object where you pass it the executor, which is a function to be executed with the resolve and reject functions, exactly. So what you're gonna do when this is being fulfilled or rejected, and the return value. So when called via new, the promise construction returns a promise object. The promise object will become resolved when either of the function resolve or reject are invoked. Note that if the call resolve function or reject function and pass another promise object as an argument, it can be said to be resolved but still not settled. See the promise description for more explanation. So resolve function and reject function are also functions, and you can give them whatever actual name you want. The signatures are simple. They accept a single parameter on any type. Exactly. In which case, the newly constructed promise state will be locked in to the promise path as part of the resolution process. Promise. The reject function has semantic close to the throw statement, so reason is typically an error instance. If either value or reason is omitted, the promise is fulfilled / rejected with undefined. In other words, the executor completion state has limit effect on the promise state. Here's a summary of the typical flow. So if resolve function is called first, the value passed will be resolved. The promise may stay pending in case another tenable is passed. Become fulfilled in most cases when a non-tenable value is passed, or become rejected in case of invalid resolution passed. And here you got this. The resolve and reject promise with resolvers. You promise that this and resolve tenable. Then you're gonna pass is now the resolve value for that you receive. Mm-hmm. It's because this is a callback that you're passing here. This is the callback that is actually passing here. The parameter is a reason, and in return is a promise. With a given reason. And the resolve. So once you get that callback, this is what you want to do for that. A promise that is resolved with a given value, or the promise passed as value. If the value was a promise object, a resolved promise can be in an array in any of the state. Okay. A resolved promise, if the value was a promise object, a resolved promise can be in any of the state, fulfilled, reject, or pending. For example, resolving a rejected promise will still result in a reject promise. Because after all, so you create now is a object promise will be assigned. So after all, these are objects that will returning is unfulfilled that value. Exactly. Logs, logs in order. Original. Okay, original cast, exactly. And then once you remove from the call stack, the event loop we're gonna call whatever it has in the Microtask queue. And in our case, we have promise with 33. We have another promise here called cast. But here we only is calling cast. So we only are invoking is the cast, which is the original callback. That is 33. Resolving tenable and throwing errors. God damn it. Okay, holy fuck. Holy moly, bro. Holy moly, bro. Holy moly, bro. Holy moly, bro. Okay. This is instance method. Unfulfilled or unrejected. That's pretty interesting. Which is what it's going to call behind the scenes. And this is the behavior what it's doing here. Depending on the handler execution result, following a specific set of rules if the handler function returns a value, doesn't return anything, throw an error, returns an already fulfilled promise, returns an already reject promise, and returns another pending promise. Then the .then schedule callback function for the eventual completion of a promise. Schedule, exactly. This is a scheduling promise on the eventual completion of a promise. Method. Both work by invoking the object.then methods. For more information about the onReject handler, see the catch reference. Then returns a new promise if you call the .then. So the idea here is that the resolve function the resolve function exactly, the promise to immediately fulfill with that value. Okay.
I said at the very start that when we run or we write and run code, what we're typically doing is taking data, storing it, and then functionality that we then apply to that data. Even as simple as I have a score for a player and I increase that score. Functionality onto data. We call our live data that's stored in our application our state. That just means the labels and the data, the values currently in our application at that moment. Good. So we have this new, it's in theory, so we have this new model for thinking about how, let's have thumbs on it. You lost me. We need to know how, so instead at 2 milliseconds, we're almost there, people, on fulfillment.
Okay. Let's go to evaluate. Yeah, let's go to evaluate now. Exactly. Let's go to evaluate now the following code.
Is an empty array. All functions in the web store command. I can't. What line, Michelle? Actually, empty. What line do we value from that function? Okay, so evaluate. Can it run? It's sitting there based. Going to be checked. print hello function to loop to be run from basically, let's say this was 1 millisecond, basically from 1 millisecond, going to be checking already, can I add this stuff back to the call stack? Can I add this print hello function back to the call? It's is going to be checking already, can I add this stuff back to the call stack? Can I add this added to the event loop is going to be checking already, can I add this stuff back to the call stack? Can I add
This diagram represents until the future is the represents is the definition of the set timeout line, right? So far so good. There's nothing wrong with that. Now the next one
function, right? Any job, which we object. What's the next line of code? Complex, one word, whatever comes back on what object?
Future data.
Very well put, Brian. Future data dot value will be whatever comes back from this background work. Well done, Brian.
Future data.
Very well put, Brian. Future data dot value will be whatever comes data
So now the next one is evaluating now the next one is evaluating now future data, future constant and dot then and dot then, which is in this particular case is this one. In this particular case is this one, my friend.
dot being passed. Very nicely structured data we get back
Response.
on the call stack, so it's really clear. Actually, I can't do this. We have teed up to go. Display. We have teed up to go. Print hello. We have teed up to go. What's our next synchronous line of code? Display. Actually, I can't do this. We have teed up to go. Display. We have teed up to go. Print hello. We have teed up to go.
Mm-hmm. And the then what? And here is the interesting part. And here's the interesting part. A promise is creating an object with the shape of, yeah. And here's the interesting part. A promise is creating an object with the shape of value and unfulfilled and unrejected. No, it's unfulfilled. It's unfulfilled. Okay. Anytime the mechanism the mechanism here anytime promise QA promise in the micro task the mechanism is here anytime the value is updated or when the time exactly when the value gets updated by the browser, okay, when the value gets updated by the browser fetch function in our case, okay, it will exactly when the value gets updated by the browser fetch function in our case, it will get triggered or it will then invoke, okay, it will then invoke if it is fulfilled, the unfulfilled array of callbacks that we pass in the .then .then or call the callback on the unrejected. The thing is this unfulfilled, then unrejected. So unrejected, and unfulfilled. Okay, unrejected and unfulfilled. So or call the callback on the unrejected like so. Exactly. Or call the callback on the unrejected when it failed. Okay, that's the core of that. And then pass such function, because it's using closure behind the scenes to do that. And then pass such function, okay, and then pass such functions to the job queue, to the spec, something that the way how the spec called that, the job to the job queue, as the specs calls it, or the just aka the Microtask Queue, and that makes a ton of sense. Like this.
So what's our next? All right. So, but come on. And so what? Quickly call my microtask from the background. Much later, microtask queue, display pass end loop. Prioritize it.
Which prioritize exactly. Which prioritize is the micro task queue. So there's a couple questions here, another caveat as well.
Print hello. That's been good. That's block, so we don't need to worry about where any of this function execution work. Ask you, you're clear on that. The promise object was auto-complete, auto had its value, and therefore triggered the on-fulfillment function, or the functions in on-fulfillment. They would be added straight to the microtask queue. The event loop would never leave the microtask queue. It would never actually reach the callback queue again. You can starve the callback queue. That means prevent the callback queue's functions from running by the microtask queue by its design. The microtask queue is designed that when the event loop is grabbing things from it, as long as there's something in there, it ain't leaving.
And this is now Microtask Queue QA. Microtask Queue QA. Yeah, Microtask Queue QA. Because that was a very interesting question.
Fulfillment function, task queue, tasks in it. Meaning, by the way, if the microtask queue,
and then value is updated in the meantime, like, I'm not sure if that would ever happen.
Question. The microtask queue, that's such an interesting question. The microtask queue is designed that the event loop doesn't leave it until it's finished all tasks in it.
Microtask queue is kind of similar to that last question. I was wondering if the onFulfill functions get added to the microtask queue, and then value is updated in the meantime, like.
Exactly. How or when does the micro test stop and pass control to the to the task queue. Okay. The Microtask queue was designed. So the Microtask queue was designed that the event loop evaluate all tasks from it before it leave.
Not sure.
They would be added straight to the microtask queue. The event loop would never leave the microtask queue. It would never actually reach the callback queue again. You can starve the callback queue. That means prevent the callback queue's functions from running by the microtask queue by its design. The microtask queue is designed that when the event loop is grabbing things from it, as long as
So when the event loop is grabbing something from the micro task, it will not leave.
there's something in there, it ain't leaving.
Exactly. It ain't leaving. It ain't leaving.
Even if you're adding more as you go.
It ain't leaving. Even if you are add more as you go. You wanna take a look at that? Check the micro task here in JavaScript. This particular case here. On the micro task here, using micro task and queue micro task. Something that we talk here, like this. Second, if a microtask add more microtasks to the queue by callback queue, those newly added microtasks executed before the next task is run. So you effectively can block now the thread here. So you can now block is the since microtasks can then self-enqueue more microtasks and the event loop continue processing microtasks until the queue is empty, there is a real risk of getting the event loop endlessly processing microtasks because of how you go about recursively adding microtasks. So there is a risk of letting the event loop to evaluate continuously the microtask queue. Okay. Yeah, there is a risk of letting the event loop to continuously to evaluate continuously the microtask queue in an endless way. Microtask queue endlessly. Okay. There is a risk of letting the event loop evaluate the microtask queue endlessly. Very, very, very important here. It's part of the gotchas.
So you can always sort of think of it as an infinite while loop on picking out tasks from the microtask queue. It's very, very interesting. I want to add a few extra conditions to this. Everybody who knows promises knows there's another property on here called status. It has 3 values it can be.
Exactly. Value, unfulfilled, rejected, and status. Whether it's pending rejected, or fulfill.
E, pending, resolved, rejected. Okay? It defaults to pending when we first return out the object. That just means I don't yet have a value in value. I don't yet have a thing stored in value. My background work's nowhere near done yet. When this background work successfully responds, that status property, we can even write it in, that status property,
Object.
and this is a visible property, that status property becomes resolved. And actually it's that that triggers the onFulfillment array of functions to run with this value. But, whatever. There's another out.
So it's a status that actually triggers that. So promise, what is the promise value by default? Pending. Okay. Now with the shape of his promise is like
What the
that.
status can get, which is rejected. Rejected is when there's some error in the background.
So when does the promise value change? That's another fucking valid question. When either a resolve or reject functions are returned. Exactly. With either a resolve or reject functions are returned from the object, from the promise object. In the case of fetch, that is handled by the browser background, by the browser background fetch API. So it's they that they assign the reject or promise. But if you want to make that happen, when you want to make that happen to work with callback APIs, now you can have much more fine control about when this will be resolved and when will be the rejected. And that's opened up an entire universe here. It's like, holy moly. Holy moly. There might be a couple of questions here. Is that now that we have much more fine control about when this async operations will happen, if we're using callback, and if we're using, for example, fetch, which is something that we don't have control, is the browser backgrounds that is is the fetch API, this background task that is telling us, hey, that's right. So is this background task that's telling us, hey, blah 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 blah. Yeah, but what about the return value? If we're gonna return a promise that resolves to a response object. So once this is done in the background, okay, by the browser. So once this promise is resolved or rejected in the browser's background, by the background browser task, it will give you a response object. It will give you a response object here. And this response object is when you have now the result from that async operation. You have the body, use header, okay, redirect, and status, and that kind of thing. And that's interesting. Because now with this async nature in JavaScript, using promises, we can have it much more control about when this task will be run sometimes in the future with a success error by returning as a result, or by throwing an error if something goes wrong with a reject. We define that logic there inside of the objects, or in the case of fetch, we say, hey, you know what, this is something that I want you to delegate that, or even in read file as well, because in the browser we don't actually do that too much, but this is also part of the API, especially here on Node. Okay, in our case, by taking a look at this, async hooks, like so. So like error handling, async hooks. This is part of the Node 2022. Holy moly! Promises execution tracking, like this. But for example, JavaScript embedded API, class, async local storage, async hooks. Let me see, is that I want to know is track async context, blah blah blah, workers. But in my case, I want to is okay, we're quite familiar with timers. So far so good. We don't need to actually understand about timers. Node provide us this particular things here. So far so good. But when it comes to handle is file system operations like this, you have promise API. Where in the F do you send me, bro? Well, we got promise example, callback example, and synchronous examples here. But in the case, I prefer to go with promise. Okay. When you file all of this, readable web stream, and ultimate here, write things like that, write files, fs promise, watch. Now this is the callback. We don't definitely want to do anything with callbacks or any synchronous task, not at all. In fact, I want to delegate that. You know, it's like I want to say something like file handle, close, file handle, I don't know. For example, read data here. Read, file handle, read. Exactly. So read data as it is. So there's also not only here in the file system, it's a file system where we can now is read the data. So if we open up here code, and then we say, hey, I want you to now is do this. Intro, Next.js, that kind of thing. The hell? Come on, man. Pick a new one. Okay. Oh, didn't? Oh, I get it. Yeah, okay. I got that in GitHub here. Exactly. Exactly, and I think if I do this, is for API design here, no, that's right. So when I take a look at this, on the handlers, users, it was here, no, what I'm looking, oh, is how can I read files, exactly, how to read files here. No, this is the router, this is the server. We want is to read a file, but we want is to read a file, but this is not to wait for that. And they got it. That's quite interesting. API or Node. Exactly. This introduction here. On the DB. No, but it's just define this. Exactly. Write file. But it comes with promises. And that is here. But it comes with promises that file or read file. Read file from this is read file, right, read file, read directory, this one, read file, because this is now in a promise way similar to the fetch API on the browser. In the case of Node, we got is this particularly facade function that is not, and I think this is something interesting to mention that and to describe that. In the case of Node.js, we get a facade function called is read file, okay, read file, but this is something that comes from the file system models. Read file, okay, read file, from the file system model, from the Promisify file system model, or from the Promisify file system model. Deal with that, bro. Exactly. From the Promisify that, from the Promisify file system models. And what's happening is that in the case of Node.js, we got a facade function called read file from the Promisify file system that similar to fetch function from the browser, browser API. It will indicate, or it will tell you when that async, or when that file is being, well, when that file is being read. Okay, so similar to the fetch function from the browser API, it will tell you when that file is being read, or it will tell you exactly. It will notify you. It will notify you if that is resolved or rejected, and that makes a lot of sense. And that's one of the core of this async nature of JavaScript, particularly to read files and do async operations. Similar to the fetch function from the browser API, it will notify you that it will notify if that is resolved or rejected. Makes a lot of sense. Makes a tons of sense. Oh my god. Oh my god. So you with promise you can have or control about when you want to defer task or how to respond when a task that you don't have in control that will be executed sometime in the future reply with some data or with some errors. And here we didn't do any, we're just assuming the best case scenario here. We are just assuming the best case scenario here. We are just assuming the best case scenario here. We're assuming it's just the best case scenario here. So now they are tenable. So it's more readable here. It's way much more readable here. It's way much more readable here. And that makes a lot of sense. Okay. Okay. Yeah, because my main issue was especially is like, how do you handle errors, bro? You know, it's like, how do you handle errors here? So that'll be all for this video. That was a very, very, very interesting video. Totally. And with that, so wrapping up promise here.
Good. I have my error handling function and I have my regular success function. That's pretty nice. That's a pretty nice model. All right. Good. So promises, web APIs, the callback, microtask queue, event loop allow us to defer our action, which is perfectly fine. But this kind of like, I have my error handling function and I have my regular success. Fine, got catch to add more error handling functions or as an alternative way about handling errors. That's a really, really nice.
Wrapping up promise.
And we're going to see our final version at the very end of today. Async await doesn't give you as pretty a way of handling errors, actually. It's in theory a step back, I guess. Maybe not. I would say step back from this very clean error handling way. Not step back, but there's a way of handling errors which is perfectly fine. But this kind of like, I have my error handling function and I have my regular success function. That's pretty nice. That's a pretty nice model. All right, good. So they step back from handling errors. Actually, async await doesn't give you as pretty a way of handling errors. Actually, it's in theory a step back, I guess.
Promise, Web API, the callbacks, the Microtask Queue and Event loops no way, allow us to defer our actions until the work exactly is a promise. Web API, also Node APIs, the callbacks, Microtask Queue, and the event loops. And I want to mention all of this. So, promise, Web API or Node APIs, callbacks, Microtask Queue, the event loop allows to defer our actions until the work is done. An API request, a timer, etc., or reading a file, waiting for some content to be loaded, some data stream for that, is completed and continue running our code line by line in the meantime. So asynchronous JavaScript is the backbone of modern web, letting us build fast, non-blocking API.
Not. Oh, it's the success function. That's pretty nice. That's a pretty nice model. All right, good. So promises, web APIs, the callback, Microtask Queue, event loop allow us to defer our actions until the work, the background heavy lifting work, the long time work, the slow blocking, our background non-blocking applications. All right, beautiful.
All right, so that'll be all for this video. Take care. Bye-bye.